Hey everybody! In this video we're going to learn about the speed of sound in different materials. So we've already compared the speeds of sound in different materials, but we'll look at why it actually travels at different speeds in solids, liquids and gases. So the one thing you should be able to do in this video at the end of it is to demonstrate how the speed of sound changes when we've got different materials. Okay. So to start this one, I want you to think back to, did you ever make these little cups on a string telephones here? So you get a paper cup or a polystyrene cup, you punch a hole in it, tie some string through, and then you give it to someone else. And as long as you pull the string quite tight, you can talk through the cup and the other person can put it on their ear, and the sound travels really quickly and nicely through the string. And that's because solids are really good at moving sound quickly. So let's have a look at why that is. Firstly, we should remember that every material, it's made up of particles. So in a gas, the particles are really spread apart and they're flying around and they're not very compact. In liquids, the particles are closer together, but they can still move around. And in solids, the particles are really tightly packed, and all they can do is vibrate. They can't actually move at all. And that all has an impact on how a sound wave can travel through each material. So it's all about the particles. So I'd say the arrangement of the particles affects how the sound wave travels. And how quickly it travels in particular. Okay. So let's have a look at why that is. So we've lined up an imaginary solid, liquid and gas here. And we can see all the particles. So if you imagine, if there's an object right at the start here, and let's just say it's a speaker attached to the end of each material here. Trying to draw that little round part of the speaker. And remember, speakers vibrate back and forth, just like anything that creates sound, and that's what makes the sound wave happen. So in the solid, as the speaker vibrates forwards, it pushes on the particles at the start here, and then they don't have very far to move until they bump into the next particle. And then that particle starts to move and it bumps into the next one. And so in the solid, because the particles are so close together, the wave moves really quickly. And so sound travels really quickly through solids. But then if we think about liquids, and remember the particles in a liquid, they're a little bit further, they're spaced a little bit further apart. So in a liquid, when the speaker pushes forwards to make a compression, then the particles here, well, they have to travel a little bit further until they bump into the next particle. And then that one has to travel a little bit further. And so everything's going to take longer to push on the next particle along. So in a liquid, the waves move a little bit more slowly compared to a solid. And then a gas, it's even longer again, because those particles are so spread out that when the speaker first pushes on the first particles, it takes a lot longer for them to bump into the next particles along. And then they all take longer to bump into the next one. So in gases like the air, that's the reason why the waves move the slowest. And we already learnt the average speed of the speed of sound. Remember, in a gas, the average speed is about 1200 kilometers an hour. In liquids like water, it was about 5,000 kilometers an hour. Much faster than air. And then solids, It depends on the solid, like all these, but it's about 10,000 kilometers an hour. Way faster than in air. Okay, so let's summarize all the different materials here. So in solids, the particles are closely packed. In liquids, they're moderately packed together. And in gases, they're far apart. And so that causes the speed of sound to change. So in solids, it's very fast. In liquids, it's moderate. And in gases, it's slower. Still pretty fast, like 1,200 kilometers an hour. Way faster than we can drive. But slower than other materials. Okay, so that's why sound moves at different speeds through solids, liquids, and gases.